Okay.
Some of the problems, you've got to use that change in temperature like 3 times.
I'm getting there.
Okay.
Okay.
Those are the ones I was.
So this is like a map. These are roads, let's say. Okay, so anytime you're on this kind of a road, you use this formula. Anytime you're on this kind of a road, you use this formula. So we can do up to how many roads, how many formulas? Nope.
6.
How do you see 6?
Because you got 3 going up, 3 going down.
You do not have 3 going down. 5. You can have one here to here. There's another one here to here. Another one here to here. Another one here to here. And the last one here to here. Or you can go down. Either way. So you have to, what's I think the trickiest part about this kind of a problem is you have to find out where on this map you are starting and where you are stopping, according to the question. So in this question, we have steam at 100 degrees. So where on here is steam at 100 degrees? Okay, boiling point, this is Celsius, so this is 0 degrees, and this is 100 degrees. So 100 degrees is here, this whole part right here. So which part is 100 degrees steam? On the right or to the left? Looking at it. To the right. So my 100 degree steam is at this corner right here. If it was up here, it would have to say more than 100 degrees, like 112. Then it would be like up here. If it was 100 degree, if that said water at 100 degrees, that would be here. We're in the liquid part at 100 degrees. Then where are we ending in this problem? Ice at 0. Because there's 2 spots where it's 0. So looking at it, it would be on the left-hand side of the 0 degree mark. So this is 0. This is 0 degree water. This is 0 degree ice. So in this problem, how many roads are we going to go down in this map? 3. So we're going to have 3 formulas. And then you add up the answers for the 3 to get the total amount.
That's why you would rely in the back of the booklet for.
Yes.
What you gave me.
Yes.
I'm looking at that going.
Yeah, look at these pretty pictures she's drawing me. Right.
Now it makes sense.
Okay, so we are starting up here, going down here. Every time you get to a corner or a new road, you have to do a new formula. So from here to here is going to be the first one. Are we going horizontally or diagonally? Horizontally, so I have to use this horizontal formula. So grams, we have 50 grams. Times the heat of what? From here to here is the heat of what? Vapors if we're going the other way. So condensation, heat of condensation, still the same number though. So times 540. That's going to give me a certain number of calories. Did you get 27,000? Good, then I'm right. But that only gets me to this part of my map. I need to get to here, according to this question. So now I'm on a new road. Is it a horizontal road or diagonal road? Diagonal, so I have to use this diagonal formula. So I still have 50 grams. We don't lose mass when we're converting between all the physical states. Times the change in temperature. Well, how much is the temperature changing if we go from here to here? 100 degrees. So 100 goes here. Because we moved 100 spots on the thermometer. Times the specific heat number. It is 1. But to get the 1, you have to look on the chart on 366 or look on the blue chart that you get in the testing center and go to there's 3 specific heat numbers. But which specific heat are we in right now? The gas, the liquid, or the solid? Which diagonal road are we on? The liquid. So you look up the specific heat of liquid water, which is 1. So that gets us to right here on our map. Are we to our final destination? Nope. So we have to go on now. What kind of a road? You guys understand that road business is all unofficial, crazy Christy talk, right? Okay. Okay. So now we're going on a horizontal road. We have still 50 grams, and now we're just 50 grams of water instead of 50 grams. We're 50 grams of cold water instead of 50 grams of really, well, cold steam. So 50 grams times the heat, yes, it is 80, but it's the heat of solidification. But it's still 80. So this breaks it down, each road that we're on, each step that we're on, each process we're doing. This breaks it down how much each one of those takes in energy, calories and heat. But the question wants to know what's the amount of heat needed to go all the way. So you just add them all up. Doesn't it look really hard, but it's really easy? I like those. I used to hate them, though, till I came up with my roadmap thing. Do you want to do another one, or move on? Pardon? That made sense? Okay. Good.
Now, you're not going to expect us to get the answers to scientific notation, are you? Because in the book they have all the scientific notation.
Well, it's not that hard. You just move. When you do scientific notation, you need one number before the decimal and then any real number after the decimal. So this would be 3.6 times 10 to the, and then you see how many spots you moved it. 1, 2, 3, 4, and it's a positive 4 because this would be a very positive thing to have in your checkbook. But if it was this 4, that would be a negative thing to have in your checkbook. So then it would have been a negative exponent. I think there's a few that do that. P.S.